Alright, to derive this one, I was about to say factor, what you're going to do is, this is a chain rule. You should see something embedded inside of something else. And to do that, basically you derive the outside. So the outside is this 2/3 power. So the derivative, you take the 2/3, put it out front, leave the 9x plus 2, and then you subtract 1 from 2/3, leaving you negative 1/3. But your next step, after you derive, so you derive the outside, you just left what's inside. Now you got to derive what's inside and multiply it by it. So the derivative of this is simply 9. Derivative of 9x plus 2 is 9. That is the answer, but we can simplify it. If we simplify this, the 9 can multiply up here, and can't the 9, when you multiply by 2, using 18, 18 divided by 3, isn't that 6? And can't negative powers drop to the bottom? So won't this be 9x plus 2 to the 1/3? So if we want to make it nice and pretty, let's move that 6 over. But there's your answer. Because 9 times 2 is 18, 18 divided by 3 is 6. That's the answer. That's how you probably want to write it. Number 24. This right here, a lot of people want to take this 3, bring it out front, and make that a 3x. No. This is a product rule. You have an x times this piece. So to do a product rule, you derive the first piece, which is 1, leave the second piece. Plus, leave the first piece, derive the second piece. Now, the second piece is this. When we derive this, the 3 comes out front, leaving you the 3x minus 9. Then you subtract 1 from 3, you get 2, second power. And then you derive what's inside. When you derive what's inside, you get 3. You got to watch out for that. Inside of this, you have, here's your chain part of it. There's the product, but with this derivative, you have a chain. Now you got a whole bunch of simplification. At first glance, you might think, oh crud, I got to FOIL this out like a 3rd power, oh my, and a squared, oh my. But when you have these problems, you always got to look for GCFs. It helps. Because when you have your 2 pieces, you want to pull out all GCFs. And what you notice when you see these 2 pieces, you see a GCF. And what GCF you see is 3x squared minus 9, sorry, 3x minus 9 squared. So actually I should pull out a 3x minus 9 squared. It's in both pieces. I can pull that out as a GCF. When I do that, when I pull 3x minus 9 squared out of this, I'm left with a 3x minus 9. When I pull 3x minus 9 squared out of this, it looks like I'm left with a 9x. Right? 3 times 3 times x looks like 9x. So I'm still not done because right here can simplify. 3x plus 9x is 12x minus 9. And still one more thing. Isn't there a GCF here? So the answer, the derivative, there's a GCF here of 3. So I could pull out a 3. I said 3x minus 9 squared. When I pull a 3 out of here, I got 4x minus 3. That would be your derivative. Now, why do I pull out all these GCFs? Because in chapter 3, you're going to be setting this equal to 0. And if I leave it right here and try to set one of these problems up here equal to 0, it'd be a little bit harder. Right here, if I set this equal to 0, can I set each of these pieces equal to 0 and solve it? It's a 0 product property. It's very useful come chapter 3.